With more than 400,000 acres of orchards stretching across fertile valleys, California stands as the undisputed leader of walnut production in the United States. Each year, the state produces over 680,000 tons of walnuts, supplying both domestic markets and consumers around the world. But the walnuts we casually snack on or bake into desserts do not simply appear on supermarket shelves. Their journey begins deep underground in carefully prepared soil shaped by years of planting patience and precision farming. From the earliest seedling stage to advanced processing facilities, every walnut reflects a long chain of human effort and agricultural innovation. So what gives walnuts their rich flavor, firm crunch, and nutritional value? Before the first nut ever reaches the ground. Walnut farming is not seasonal agriculture. It is long-term orchard management built on patience planning and deep biological understanding. The process begins with the careful selection of walnut varieties. Growers choose cultivars based on kernel quality, shell strength, yield stability, and resistance to regional pests and diseases. Most commercial walnut trees are not grown directly from seed. Instead, farmers rely on grafted seedlings combining strong rootstocks with high-performing scion varieties to ensure uniform growth and predictable production. Young walnut trees are first raised in nurseries where soil composition, moisture, and temperature are tightly controlled. This early phase allows roots to establish properly before facing open field conditions. Once the seedlings are strong enough, they are transplanted into orchards laid out with precise spacing. Tree rows are aligned to maximize sunlight exposure, airflow, and machinery access, critical factors for long-term productivity. Walnut trees demand careful water management. Deep root systems require consistent moisture, but excess water can cause root disease. Modern orchards rely on drip and micro-sprinkler irrigation systems that deliver water directly to the root zone, minimizing waste and improving efficiency. Soil health is another long-term priority. Organic matter is added regularly to improve structure and microbial activity. Nutrient programs are adjusted annually based on soil and leaf tissue analysis, ensuring the trees receive balanced levels of nitrogen, potassium, phosphorus, and trace minerals. Pruning plays a critical role throughout the tree's life. In early years, pruning shapes the structure of the tree. In maturity, it improves light penetration and airflow, directly influencing nut size and quality. Once mature, walnut trees can remain productive for 30 to 50 years, making each orchard a generational asset rather than a short-term crop. Walnut harvesting is the narrow window where precision determines quality, profitability, and shelf life. Unlike many fruits, walnuts do not ripen further after harvest. They must be collected at the exact moment nature signals readiness. As late summer transitions into early fall, the walnut's green outer hull begins to split open naturally. This is the visual cue growers watch for across thousands of acres. Harvesting too early results in underdeveloped kernels. Too late increases the risk of mold staining and quality loss. Modern harvesting relies on mechanical tree shakers. These machines grip the trunk or major branches and apply calibrated vibrations. In a matter of seconds, ripe walnuts detach and fall to the orchard floor. The force is carefully controlled to protect both the tree and future crops. Once the nuts are on the ground, speed becomes critical. Mechanical blowers push walnuts into clean rows, separating them from leaves and debris. Sweepers then gather the nuts into centralized lines, where harvesters lift them into large bins or trailers. This mechanized process allows a single operation to harvest hundreds of acres in a short time, something that would be impossible with manual labor alone. However, human oversight remains essential. Operators constantly adjust equipment settings based on soil conditions, tree age, and nut density. The goal is simple but demanding. Remove the walnuts quickly, cleanly, and gently, preserving kernel quality while preparing them for immediate processing. Once walnuts leave the orchard, they enter an industrial ecosystem designed for speed, hygiene, and consistency. Processing begins almost immediately to prevent moisture retention and quality degradation. At the facility, walnuts pass through vibrating screens that remove dirt, stones, and plant material. This is followed by intensive washing, where high-pressure water systems clean every surface of the nut. Cleanliness at this stage is essential for food safety and long-term storage. Drying is the most critical processing step. Walnuts are placed in large drying systems where temperature, humidity, and airflow are precisely controlled. This process reduces moisture content to safe levels, preventing mold growth, while preserving the nut's natural oils, flavor, and nutritional value. After drying, walnuts move through automated sorting systems. Screens and rollers separate nuts by size and weight, while optical scanners detect defects, discoloration, or shell damage. These machines can process thousands of nuts per minute with remarkable accuracy. Yet even with advanced technology, human inspection remains indispensable. Skilled workers visually examine samples, removing defective nuts that machines may overlook. This hybrid system automation, guided by human judgment, ensures consistency at industrial scale. From here, walnuts are routed according to their final destination. In-shell markets, shelling facilities, or further processing plants. Walnuts destined for shelling undergo another transformation. Specialized shelling machines apply precise pressure to crack the hard shell without damaging the kernel inside. The mixture of shell fragments and kernels then passes through air separation systems, vibration tables, and fine screens to isolate the edible portion. Optical sorting systems scan kernels for color, shape, and defects. Final manual inspection ensures only premium-grade walnuts continue to packaging. This level of scrutiny is what allows walnuts to meet strict international quality standards. Packaging varies by market. Retail walnuts are vacuum-sealed or packed in nitrogen-flushed bags to preserve freshness. Bulk walnuts are loaded into large food-grade containers for bakeries, confectioners, and global distributors. Automated packaging lines handle weighing, sealing, labeling, and palletizing with minimal human contact, ensuring hygiene and uniformity. Finished products are stored in climate-controlled warehouses until distribution. From there, walnuts travel across the country and around the world. Appearing in grocery stores, restaurants, bakeries, and kitchens far from the orchards where they began. Behind every walnut is a network of people, farmers who plan decades ahead, machine operators who fine-tune equipment, technicians who maintain processing lines, inspectors whose eyes ensure quality beyond what sensors can detect. Walnut farming represents a balance between tradition and innovation. Each nut carries the legacy of California's orchards, the dedication of its farmers, and the quiet efficiency of modern agriculture. Thank you for joining us on this behind-the-scenes journey. If you found this story insightful, feel free to share your thoughts and explore more agricultural stories that connect the land to our everyday lives. Did you know that every year more than 40 million tons of cucumbers are harvested worldwide? Behind this seemingly simple vegetable lies a vast global system supplying fresh produce and millions of jars of pickles enjoyed in households every single day. From lush green fields to highly controlled processing facilities, cucumbers travel a carefully managed journey, shaped by tradition, science, and modern agricultural technology. In this video, we follow that journey step by step, discovering how fresh cucumbers grow, how they are harvested at scale, and how they are transformed into products found on tables around the world. Farmers typically select loose, well-drained soil with a slightly acidic to neutral pH, allowing roots to expand freely while retaining enough water to support steady growth. Before planting, the soil is deeply cultivated and enriched with organic matter, such as compost or aged manure. This not only improves fertility, but also enhances microbial activity, creating a living environment that supports healthy root systems. Modern seed sowing machines are then used to place cucumber seeds at precise depths and spacing, ensuring uniform germination and reducing competition between plants. As seedlings emerge, daily care becomes critical. Cucumbers require consistent watering, especially during flowering and fruit development. Too little water can lead to bitter or misshapen fruit, while excess moisture can suffocate roots and promote disease. To maintain balance, many farms rely on drip irrigation systems that deliver water directly to the root zone with minimal waste. Ventilation and sunlight exposure are carefully managed, particularly in greenhouse or covered field systems. Farmers regularly monitor for pests and diseases, such as powdery mildew, leaf miners, and fungal infections. Pollination is another defining stage. Bees and other insects play a key role in transferring pollen between male and female flowers. In areas where pollinators are limited, farmers may assist manually to ensure high fruit set. Once pollinated, cucumbers develop rapidly, transforming within just a few weeks into firm, smooth-skinned fruits, ready for harvest. Harvesting cucumbers is a time-sensitive operation where speed and accuracy determine final quality. Cucumbers must be picked at the right size and maturity, often within a narrow window of just a few days. Harvest too early and flavor and texture suffer. Harvest too late, and the fruit becomes oversized, seedy, or unsuitable for processing. On large commercial farms, modern harvesting machines have replaced most manual labor. These specialized harvesters gently lift cucumbers from vines using rollers and conveyor belts, designed to minimize bruising and surface damage. As the machines move steadily through the fields, ripe cucumbers are collected, while immature fruits are left behind to continue growing. Advanced systems allow for preliminary sorting directly in the field. Damaged or misshapen cucumbers are separated immediately, reducing the volume transported and improving overall efficiency. High-capacity machines can harvest several tons per hour, allowing farms to respond quickly to market demand and weather conditions. Throughout the harvesting process, protecting freshness is essential. Cucumbers are shielded from prolonged sunlight and excessive heat, helping preserve their crisp texture and natural moisture. This combination of mechanical precision and careful handling ensures consistent quality across massive production volumes. Once harvested, cucumbers move rapidly from fields to processing facilities. Time is critical as freshness begins to decline immediately after harvest. Upon arrival, cucumbers are thoroughly washed to remove soil debris and any surface residues, ensuring compliance with food safety standards. Automated grading systems then sort cucumbers by size, shape, and surface quality. Premium grade cucumbers are directed toward fresh markets or export channels, while others enter processing lines for pickled and preserved products. For processing, cucumbers are transferred into climate-controlled environments where temperature, humidity, and sanitation are strictly regulated. In pickle production, cucumbers are immersed in brine solutions made from water, salt, vinegar, and carefully selected spices. This stage can last from several days to several weeks, allowing flavors to develop while preserving the fruit's signature crunch. Modern factories rely on automated slicing, filling, and packaging lines to maintain uniformity and hygiene. Glass jars and containers are sterilized before filling, and every batch undergoes inspection to ensure consistent quality. Cold storage and logistics systems then prepare finished products for distribution to domestic and international markets. By the time cucumbers reach consumers, they exist in many forms. Fresh cucumbers appear on grocery shelves, while processed versions become pickles, relishes, and ingredients in countless meals around the world. Each product reflects a different stage of transformation from raw produce to carefully preserved food. Beyond their culinary uses, Cucumbers offer important nutritional benefits. Their high water content supports hydration while fiber aids digestion. Vitamins such as C and K, along with essential minerals, contribute to overall health. Cucumbers are also valued for their antioxidant properties and their role in skincare and wellness products. From a single seed planted in fertile soil to a finished product enjoyed across continents, cucumbers demonstrate how modern agriculture blends tradition, technology, and scale. What seems like a simple vegetable is in reality the result of a carefully coordinated system designed to deliver quality, consistency, and nourishment to millions of people every day. Behind every cucumber harvest are farmers combining experience with innovation. Smart sensor systems now monitor temperature, humidity, soil moisture, and pH in real time, allowing farmers to adjust irrigation, nutrients, and shading precisely. This integration of human knowledge and modern technology reduces waste, increases yields, and supports sustainable farming practices. If you enjoyed exploring how cucumbers are grown, harvested, and transformed, share your thoughts in the comments. Have you ever made pickles at home, or do you have a favorite cucumber dish? Thank you for watching, and don't forget to like and subscribe for more stories from the world of agriculture and food production.